So I just want to make a quick video on all the different ways that we know how to factor a trinomial where a is not 1. So there's no common factors that I can take out. So probably one of the most tried and true and favorite methods is called guess and check. So usually that's where you take, I'm going to rewrite it over here, 6x squared minus 19x plus 15. Okay, so if I want to factor this, you start off by writing the factors of the two n numbers. So things that multiply to be 6 are 1 and 6 and 2 and 3. And then for 15, 1 and 15, 3 and 5. These are called, I don't know, I'd say make your t's. So, because you made a t on each side and then you do that in there. So what I'm trying to do is I'm trying to find a pair of these that matches up with a pair of these such that I'm going to multiply the numbers together and then add their answers, and I want to end up at a negative 19. So, for example, let's say I took the top two pairs. I could either multiply the 1 and the 1 together to get 1, and the 6 and the 15 together. What's 6 times 15? 8. What? 60 and it's 90. Yeah. So 1 plus 90 is nowhere near 19. So that's not the right pair. Okay? And since they have to multiply to be a positive number but add to be negative, aren't both of my factors going to be negative? Right? To multiply to be a positive but add to be a negative? So both of them are going to be negative. Anyway, 91 or 90 and 1 are nowhere near 19, so that's not the right pair. Maybe I try 2 and 3 with 1 and 15. So I could do 2 times 1, which is 2. 3 times 15 is 45. I'm still way too far away from 19. So maybe you do it the other way. Maybe it's 3 times 1, 3. 2 times 15, 30. I still can't get to 19, so that's not the right pair. Let's try these two. Maybe I do 3 and 30. Nope. Or maybe I try 18 and 5. Getting closer, but that's still not the right pair. Let's try these. Oh, look, I have it. 10 and 9. So if I have negative 10 and negative 9, they'll multiply together to get me a positive number, but add to be negative 19. So here's what I do. Once I find the pairs, I circle them. It was negative 9 and negative 10. I jot those numbers down just so I don't forget them. So I circle them, and I put how I'm getting to negative 19. I just jot that down. And then watch this. You make your two factors. These two numbers go in the first spot of each binomial. So it's a 2x and a 3x. Because it's really factors of 6x squared, right? So if I multiply those two numbers together, I get 6x squared. But now I'm going to, basically you're going to be foiling these two together to get back to this. So eventually I'll be multiplying these two together and these two outer ones together. I need to do 3 times something to get either a negative 9 or a negative 10. Well, I can get a negative 9 by multiplying 3 times something, right? 3 times what gets me a negative 9? And look, these are the two numbers that I have to place. So I just put a negative 3 right there. Now it's pretty easy. I have to put a 5 in, and I need to make it a negative 10. So 2 times what gets me a negative 10? Negative 5. So those are my two factors. If you foiled these two back together, that's going to get me back here. Okay? So that's sort of my quick recap of guess and check. So that's kind of how that goes. Yeah, so okay, let me tell you what's nice about this way. What's nice about this way is the biggest number I ever dealt with was 19, right? Even the factors. I'm only dealing with factors of 6 and 15. They're not that big of numbers. It's especially quick if you have prime numbers on the end, then you can do this really fast. And the more you do it, the quicker you get. Like, you know, eventually you get to the part where you don't even need to list the factors. Some of you can just do it in your head, right? It just is, you just got to get good at it. But that's pretty much the process. You may do it slightly different, but that's the concept. You're kind of guessing which pairs will match up to get exactly what you want here. You can always foil this back together to make sure that it's the right combo. Because if you had 2x minus 5, and 3x minus 3, that's not going to work. That's not going to FOIL back together to get you this. It has to be these two binomials. Okay? So there's guess and check. Then there's another very common method that has all different names. Factoring by grouping, the AC method, the British method I've heard it called. I don't care what you call it. I don't care what you call any of these methods as long as you have a way that works. Okay, so this way makes you multiply A times C together. So I do 6 times 15. And we got that number, which was 90. Now you're looking for factors of 90 that add up to be a negative 19. Okay? That's pretty easy. In this one, it's just negative 9, negative 10, right? So once I have those two numbers, right? Well, let's pretend that you didn't realize that first. You do need two numbers that multiply to be a positive 90 but add to be negative 19. So maybe at first you're like, oh, I don't know what they are. Negative 1 and negative 90? Nope, those add to be negative 91, so that's not right. How about negative 2 and negative 45? Nope, that adds to be negative 47. So you keep going until you find the right pair, okay? So I just happen to negative 9 and negative 10 jump out. They add up to be the negative 19, okay? So I go through my factors until I find the right factor pair. Once you find that factor pair, you're basically going to rewrite this trinomial, but you replace the middle term with these two. So it looks like this, 6x squared minus 9x minus 10x plus 15, right? Because negative 9x and negative 10x, if I put them together, I really have that. The whole point of doing this is now you can factor by grouping. So what we do is I literally draw a line after the second number, and then you just factor each side. So what can I take out of 6x squared minus 9x? 3x. And then what's left over is 2x minus 3. What can I take out of this side? You could take out a 5. Watch what happens. Well, I want to show you what happens if you do take out a positive 5. If you take out a positive 5, you're going to be left with negative 2x plus 3. Now, these two sets of parentheses are supposed to match perfectly. So you can see, oh, you know what? I'm only off by the sign. That's a clue to you. Hey, I should have taken out a negative 5 instead of a positive 5. So if I take out a negative 5, that will leave me with a 2x minus 3. In this method, these two parentheses have to be identical. If they are not, there's something wrong. Either you messed up somewhere. So don't even bother going any further because something's not right. Once you have these two factors, guess what? I can factor that factor out of the whole thing. So that just becomes one of my two. It's going to be 2x minus 3 times, what's the other one? It's just what's out in front, 3x minus 5. So, as you can see, I got the same answer that I got the last time. It's just a different method. So, what's nice about this method is it's pretty straightforward. You just multiply. Once you get the steps down, it's kind of easy. The bad part is now you're dealing with a much bigger number. I have to deal with factors of 90 instead of just 6 and 15, which were a lot smaller. 90 has a lot more factors. But, True. So you do only have one number instead of dealing with factors of two numbers. So if that's what works for you, that's fine. There's one more third method, which I actually think is my favorite, but kids mess it up most frequently, so maybe you don't. I'll show it to you, but it's very common that it gets messed up. So here's our same quadratic, 6x squared minus 19x plus 15. Okay, this one starts very similarly to the last one. We still multiply a times c, but what I do is I drop off the a and I just do a times c right here. So now it's as though I have a quadratic where a is 1. And now I factor this just like I normally would factor something that had a equal to 1. So factors of 90 that have to be negative 19, x minus 10, x minus 9. The problem with this method is that a lot of kids stop here because they think that they're done, but obviously that's not the right answer, is it? That's not the answer that we got the other 2 times. Here's what they forgot to do. When you multiplied by 6 here, you now need to come in and divide both of these by 6. Okay? And now watch this. So let's simplify this fraction. That becomes what, 5/3? Right? If I reduce 10/6, I get 5/3. And now if I reduce 9/6, that's 3/2. So you reduce the fractions, and then watch this cool little trick. Whatever the denominator is, sneaks around and comes, you just stick it right in front there. What? So you get 3x minus 5 and 2x minus 3. That's so weird. So this method, I personally do this one fastest. I don't know. This is the one that I like. But I hesitate because so many kids stop right here because they think that they're done. And clearly that's not the right answer. But this is. So, those are the 3 different ways that I know. I don't know if any of you have a different way. But those are the 3. There's a lot of variations on the 3 where you're basically doing the same thing. Like this one, there's something with a box, but you're doing the same math. It's just set up in a box instead of like this. And this way, we don't have a name for it. This, honestly, you know where this one came from? This was so funny. Some kid in Mrs. Swanson's class, like 5 years ago, was like, oh yeah, my girlfriend showed me how to do this method. And we were all like, what? Like no one had ever seen it before. So we were all amazed. It was a big deal. But it works as long as you have to make sure that you don't have, you had to have taken a common factor out already. If there is a common factor and you don't take it out, you're not going to get the right answer. So there's the 3 different ways that you can factor a quadratic where a is not 1.